I want to tell you about the moment I understood that power generation didn't start where we've been told it started. It wasn't dramatic. It wasn't a conspiracy document or a secret journal. It was quieter than that, and somehow more disturbing because of it. It was a Sunday morning, and I was cross-referencing industrial surveys from the 1740s, infrastructure maps from the Austro-Hungarian Empire, bureaucratic documents, the kind of material that buries truth through sheer tedium because no one reads it. And I found something in a footnote. An annotation referring to massive structures recorded in the Danube Valley region, described as ancient millwork requiring partial demolition. Ancient millwork, in the 1740s. Ancient is a word that doesn't belong there, not in a document about 18th century infrastructure. And then I read the specifics, and I understood why that single word was so carefully chosen. The structures in question weren't mills. They couldn't have been, not with those specifications. The height-to-span ratios were impossible for grinding grain. The internal canal systems showed evidence of fluid distribution, not drainage for water power, but collection and dispersal networks. Pressure tolerances in the structural engineering, mentioned only in passing, exceeded anything grain milling would require. By almost an order of magnitude. I closed the survey. I opened another. Then another. And that's where this investigation begins, not with the steam engine, not with Thomas Edison or Nikola Tesla, not with the triumphalist narrative of electricity's discovery. No. This begins with something older, something that doesn't fit the timeline at all. What is a power plant? Let me ask you something simple. What is a power plant stripped of everything modern? Remove the turbines, the transformers, the transmission towers, the electrical substations. Remove everything invented after 1850. What remains? At its core, at its absolute functional core, a power plant is a collection of very specific things. You need a source of energy, moving water, falling water, thermodynamic pressure, fluid circulation. You need conversion structures capable of translating that energy into usable form. You need distribution infrastructure, channels, conduits, piping capable of moving the converted energy across distance without catastrophic loss. You need receiving stations. You need storage capacity. You need regulators, valves, gates, mechanisms that control the energy flow with precision. And you need it to work continuously, reliably, day and night without fluctuation. That's a power plant. That's what the function demands. Now, with that definition in mind, that purely functional definition, technology agnostic, I want you to look at something the official historical record has categorized as something else entirely. Structures we've been taught to understand as watermills, hydraulic grist stations, medieval grinding infrastructure, ancient manufacturing complexes. Because here's what I found, across multiple regions, across multiple centuries of historical records. There exist complexes of architecture that fit the functional profile of a distributed power generation network almost perfectly. Not partially, not approximately, precisely, with a precision that becomes impossible to dismiss once you start documenting it. The Danube complex let me describe what was actually built. In the regions surrounding the Danube, and particularly in the sections flowing through the Balkans and Central Europe, there exist what historians have categorized as a network of ancient hydraulic installations. The surveys are fragmentary. Some are lost, but the ones that remain are documented with technical precision by 18th century engineers whose job was inventory, not interpretation. According to these records, the structures shared consistent architectural characteristics. Main collection basins with precision-engineered inlet systems. Intake channels carved, and this is important, carved into bedrock with consistent gradient tolerances of less than 1 foot per 100. Not the rough, variable channels you'd expect from medieval construction. These were engineered. The conduit systems showed evidence of multi-stage pressure management, not one pipe from A to B. Multiple parallel channels, each with separate valve stations, each monitored, with measurement points cut at specific intervals. I'm not saying this was electricity. I'm not claiming that. But I am asking, what grinding operation requires pressure management at 3 separate stations? What grain mill needs monitoring points? And then there are the receiving structures. The facilities at the terminus of these networks don't match milling infrastructure. The floor plans show centralized distribution chambers with what can only be described as radiating distribution lines, multiple exit points, multiple outputs. The walls show reinforcement patterns, suggesting they were designed to withstand internal pressure. The structural tolerances recorded in the surveys exceed what wooden milling machinery would require by factors of 4 or 5. One survey from 1782 describes a structure in the Danube Valley as a complex of channels terminating in a distribution chamber of unprecedented magnitude. The chamber itself measures 180 feet in length and 60 feet in width, with internal walls constructed of face stone set in lime mortar. The purpose, if originally industrial, is no longer evident. The structure is in fragmentary condition, and local records offer no account of its function. 180 feet, 60 feet, with multiple output lines for grinding grain. According to the accepted historical narrative, the coordinate problem. Now let me step back, because there's something much larger happening here. These structures didn't exist in isolation. They were part of systems, networks, and these networks, according to the fragmented records we have, existed across multiple regions simultaneously during compressed time periods. In the Danube Valley, evidence of coordinated construction from the 1600s to the early 1700s. In the Alpine regions, parallel systems documented by Swiss engineers using identical architectural principles built during the same century. In the Rhine Valley, infrastructure that Swiss and Dutch engineers worked on cooperatively, their correspondences surviving in archives. Discussing standards and specifications as though implementing a larger plan. I'm not saying there was a coordinated plan, I don't know. But I am asking, how do you build precision-engineered hydraulic networks with consistent tolerances, with distributed monitoring systems across multiple regions? With coordination that required the systems to communicate with each other, without documentation, without planning, without specification sheets, yet the only documentation we have is fragmentary, surveys describing structures already in decline, records using passive language. Ancient installations, purpose unclear, fragmentary evidence. The specification documents, if they ever existed, are absent. All that remains is the material evidence, the structures themselves. Measured, documented by skeptical engineers, described in language that avoids interpretation because the engineers who wrote it didn't want to admit what they were looking at. The supply chain problem, and then there's something else that keeps me awake. These structures required resources, materials, labor. The quarrying of precision-cut stone at the volumes required for these complexes would have left archaeological evidence. Quarry sites, tool marks, production centers. For a system this large, this distributed, this coordinated, you would need multiple quarries operating simultaneously across multiple regions. We don't see that evidence. The quarries that should exist, the mining records, the labor camps, are either absent or described as medieval stone extraction sites of unknown purpose. The metals required for the valve systems, the measurement instruments, the reinforcement bands, these would have required metallurgical capacity. Iron, copper, bronze in quantities that should show up in production records, trade ledgers, mining permits. The records don't exist, or rather, they exist as shadows. References to metallurgical sites producing output that officially went nowhere. Shipments recorded but not accounted for. Production figures that don't match documented construction projects. I'm not saying this is evidence of conspiracy. I'm saying this is absence of evidence. And absence of evidence at this scale becomes evidence of something. When you can document resource extraction that should have left a trail, and that trail simply isn't there. When the materials disappear into projects that officially never happened, you're looking at either falsified records or deleted records. Either way, something is being hidden. The energy problem, the question that matters most is this: what was the energy distributed to? We know the networks existed. We know they were built with precision. We know they coordinated across regions. We know the documentation about their purpose is deliberately vague, but what were they powering? If these were mills, there should be mills, archaeological evidence of milling operations, grain storage facilities, trade records of flour production, distribution networks for the output. We don't find these at the scale the energy networks suggest. If these were mines, there should be extracted materials, or records, processing facilities, shipping documentation for the product. We don't find these either. If these were manufactories, textile mills, metalwork, precision production, there should be goods, inventory records, trade regulations, quality control documentation. All the bureaucratic overhead that accompanies industrial production. Instead, what we find are energy systems designed to produce more than any documented operation would have required, distributed to locations where we can't account for the output. The energy went somewhere. It had to go somewhere. You don't engineer systems this sophisticated without intention, without purpose, without a destination for what they produced. Here's what I think happened, and I'm carefully not claiming this as fact. I'm offering it as the most parsimonious explanation for what the evidence suggests. The technological capability to generate, distribute, and utilize substantial energy existed at a level of sophistication we don't typically associate with the pre-industrial world. Not everywhere. Not universally, but in specific regions, among specific populations with access to specific knowledge and resources. This knowledge was not preserved. It was suppressed, destroyed, or allowed to fall into disuse through the systematic elimination of the people and documents that maintained it. The structures were left standing. You can't destroy a mountain valley's entire infrastructure without attracting attention, but they were reframed, renamed, categorized as ancient, medieval, purposeless. The documentation that explained their function was destroyed or compartmentalized, placed in archives so obscure, and so carefully indexed to obscure rather than clarify that they might as well have been destroyed. And the knowledge itself was displaced by the new frameworks. When you have a consistent narrative, electricity was discovered in the 1700s, power generation began in the 1800s. Industrial capacity emerged in the 1900s. Then evidence of older systems doesn't register as evidence. It registers as error, misdating, misinterpretation. I'm not saying this was a single coordinated act. I'm saying that the loss of knowledge is sometimes better explained by systematic replacement than by conspiracy. Belief systems are powerful. Once you're convinced that power generation requires a specific set of prerequisites that didn't exist before a specific date, you simply won't see the evidence that contradicts you. And here's where the pattern becomes impossible to ignore. The structural degradation we see, the ruined installations, the fragmentary systems, the ancient complexes doesn't match natural decay patterns. The timelines don't fit. These structures were built to last. They're made of stone, cut with precision, designed to withstand pressures that would destroy casual construction. Yet the records describe them as in decline by the 1700s, as abandoned by the 1800s, as completely forgotten by the time electricity was discovered. That's not natural decay. That's deliberate dismantling, systematic abandonment, or worse. And as these systems were dismantled, the intellectual frameworks were rebuilt. The knowledge required to build them, not the technology but the understanding of energy systems, pressure mechanics, long-distance transmission, this knowledge disappeared, or was destroyed, or was deliberately replaced with frameworks that made this older knowledge seem impossible. Once you've decided that real power generation requires thermodynamic principles developed in the 1850s, then evidence of working power systems that predate those principles stops making sense. Your mind doesn't register it, or registers it as anomaly, misdating, primitive approximation, not as lost knowledge. I'm going to stop here because I don't have answers to the deepest questions. I have evidence of precision-engineered infrastructure designed for energy distribution. I have documentation of coordinated systems across multiple regions. I have records of materials and resources that should have left traces but simply vanished. I have testimony from skeptical engineers who clearly saw what these structures were, even if their language avoids saying so directly. But I don't know what was generated. I don't know who maintained this knowledge. I don't know whether this was global or localized.